And so, to keep track of how much Voyager had rotated, it had an onboard gyroscope, which could be used for several hours at a time. This was a disc mounted on a 3-axis gimbal. When activated, the disc would spin and its angular momentum would keep it perfectly stable. As Voyager rotated, the gimbals would rotate around this disc and a device would measure how much its orientation had changed. Voyager then knew exactly how much it had to rotate in order to return to its Earth-facing position. This entire system worked very well and gave Voyager a fixed orientation in space. But knowing the orientation was only part of the problem. In order to plot its trajectory, NASA needed to know how fast it was going. They did this by sending a signal out to Voyager and timing how quickly it would respond. Since each signal traveled at the speed of light, multiplying these two numbers would give them Voyager's distance. Then they'd send another signal, which would give them Voyager's new distance. By subtracting these distances, they could figure out how much Voyager had traveled in that time. With this, a simple calculation would tell them how fast Voyager was traveling. With all of these data points, NASA could continuously plot Voyager's trajectory and see how it compared to the desired trajectory. If the space probe was a bit off, they could send a command to Voyager, which would fire up its thrusters to fix it. With this incredible system, Voyager arrived at its Jupiter target point just 1.4 seconds late and only 60 kilometers off course. As Voyager 2 approached Jupiter, its speed had slowed considerably to around 10 kilometers per second as it reached the top of its orbit. This was now well below the Sun's escape velocity, which, at Jupiter's distance, was around 18 kilometers per second. But as it got closer to Jupiter, its gravitational pull started to have an effect on the space probe. Since Jupiter was already moving very fast in this direction, it pulled Voyager in and essentially multiplied its current speed with Jupiter's speed, sending it off at an even greater velocity. Voyager was now going faster than the Sun's escape velocity, and from this point onwards, it was destined to escape the solar system. But the journey wasn't over yet. Voyager went on to complete 2 more gravity assists around Saturn and Uranus, making incredible discoveries along the way. The final gravity assist would be around Neptune, but this gravity assist would go a little bit differently. Since there were no more planets to visit after Neptune, Voyager didn't have to follow any particular path around Neptune. However, scientists were very interested in flying as close as possible to Triton, one of Neptune's moons. But Triton orbits at a steep angle, and so getting close would require a dramatic change of direction. And so, instead of approaching from behind Neptune, Voyager approached just a tiny bit in front, heading over the planet's north pole. This was enough to bend Voyager's trajectory downwards, whilst also slowing it down. 5 hours later, Voyager flew past Triton, and from then on began its lifelong journey into deep space. This epic journey took 12 years in total, and the discoveries that Voyager made along the way taught us an incredible amount about our solar system.